What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over example 5 and example 6 of how to solve math problems that are dealing with compound interest. How to solve math problems that are dealing with compound interest. Real quick, guys, I just want to recap, guys, the difference between simple interest and compound interest, right? Interest is this extra equity or extra value that's added to a principal or a start balance, okay? So, for example, if it's simple interest, the simple interest can only be applied to a principal or a start balance only once a year, which is annually, right? But compound interest, right? That interest can be applied multiple times in a year, whether it's half yearly, meaning twice a year, quarterly, that means every season, which is 4 times a year, monthly, which is 12 times a year, because there's 12 months. There's 52 weeks in a year, so if it's compounded weekly, it'll get compounded 52 times, okay? That interest. So it just keeps stacking and stacking and stacking within that year period. Okay, so that's just one thing that I just wanted to go over, guys. It's a recap of that. Now let's go ahead and go over example 5 and example 6. All right, as we can remember, guys, the formula to find out the final amount when you have compound interest, not simple interest, compound interest is A, which is the final amount, equals the principal times parentheses 1 plus the interest rate, which is R, divided by N, which is the number of times the interest rate will be compounded. So if it's quarterly, it'll get compounded 4 times. If it's monthly, it'll be 12 times, and so on, right? Parentheses close to the N times T power. T is the number of years, okay? So that is the formula that we're gonna follow, guys. And remember, guys, the principal is the start amount, right? Or the initial balance, okay? So let's go ahead and start, guys. Let me get my calculator. Make sure you have a calculator, guys, when you do these type of problems, all right? Because the numbers can definitely get wacky dealing with the exponents, okay? So in the first example, guys, and once again, we're gonna cover both examples. So let's start off with example 5. In example 5, guys, the question asks, what would be the ending balance, okay? And they actually gave us the principal. The principal or the start amount is $9,500, right? And it's going to get hit with an interest rate of 7%, right? And this interest rate is going to be compounded monthly within a year, right? So every year is going to be compounded monthly. And monthly means 12 times, okay? So it's going to get compounded 12 times, all right? And the multiplication sign is letting you know how many times it's getting compounded within that year, right? So it's going to get compounded monthly. And the number of years, guys, that they want us to check after is 8 years, okay? So actually, guys, in this particular problem, they have given us everything that we need to know. All we need to do, guys, is just plug in these values correctly into the formula, okay? So let's go ahead and do that. Excuse me. All right, so I have A, which is the final amount, equals P, which is the principal or the start amount, which was $9,500. So I'm gonna have $9,500 or $9,500, however you want to say it. All right, times parentheses 1 plus. Okay, now I'm at this part, guys. The interest rate in this particular case, guys, is 7%. Okay, remember, guys, in order for us to put the interest rate correctly into the formula, we have to change it from a percent to a decimal. So 7%, if you move the decimal place 2 times to the left, it will equal 0.07 or 0.07, all right, which is the same thing, okay? So this is the decimal that is gonna turn into, guys. All right, so that's what we're gonna put into the formula, okay? So once again, the interest rate is 7%, which is 0.07 as a decimal, over N, which is how many times it's gonna be compounded within a year, which is monthly, which is 12 times, okay? So N is 12, parentheses close, all right? And then it's gonna be to the N times T power. Once again, N is monthly, which is 12 times. So it's gonna be to the 12 times, and T, the number of years is 8. So it's gonna be 12 times 8 power, okay? So that's how it's going to look, guys. That's how it's going to look, guys. So now we have successfully plugged in all our values within the formula. All we need to do, guys, is simplify it down to a single answer or a single value that's an answer, okay? So now let's go ahead and do that, guys. Okay? Now, the first thing, guys, that we want to do, guys, remember auto operation, PEMDAS. We want to start off with the parentheses first. We want to solve inside the parentheses. We're going to solve 0.07 divided by 12, right? And then we're going to add that to 1. All right? So 0.07 divided by 12 equals 0.00583, okay? It is actually a repeated decimal, but I'm just going to stop there. All right? So it equals 0.00583. Okay? 0.00583. All right? And then, of course, guys, I know that if I add that to 1, it will be 1.00583, which I'm going to do in the next step. Okay? The second thing that we want to do, guys, is we want to simplify the exponent. Okay? The exponent is 8 times 8, but we want to simplify that down to just a single value. 12 times 8 is 96. 12 times 8 is 96. So the exponent is actually 96. So now what we're going to do is, guys, we're going to rewrite everything, all right, in a more simplified version, and then we're going to solve all the way by plugging into the calculator. All right, so once again, my principal was 9,500 times parentheses 1 plus 0 plus 0.00583 equals 1.00583. All right, so simply that's what it equals to, guys, as I add both of those values together. And remember, guys, it's to the 96 power. Okay, it's to the 96 power. And literally, guys, all you have to do, guys, is just plug in this particular expression into a TI-84 calculator, and then you will get the answer. So that's what I'm going to do, guys, to get the final amount. So I have 9,500 times parentheses. I'm going to do 2 parentheses because I want the exponent to be within so it won't get mixed up in here, guys. This is a certain way to put it into the calculator. Times parentheses 1.00583, parentheses close, to the 96 power, and outside parentheses close, okay? So as I multiply those numbers and solve that, guys, my final value is going to be 16,000, or approximately, I'm gonna do approximately because I'm gonna have to round up a little bit. All right, $16,599, right? And 7 cents. All right, and 7 cents. That is this right here, guys, is the final amount. Okay, that is the final amount after 8 years. Okay, so once again, if you were to invest $9,500 at 7% interest, right, and it's compounded monthly, and you do this for a 8-year span, you should have $16,599.07, roughly around that, as your final amount, okay, after 8 years, okay? So what we're gonna do is, guys, we're gonna do the same thing for this problem. It's a little bit more context. We're gonna read it, and then we're gonna actually plug in the values where they go, all right? So the same thing, guys, we're gonna solve for the same thing for example 6. It reads, you finance a $150,000 mobile home for 20 years at 5% interest, compounded monthly. That is very, very important, guys. That is very, very important. Compounded monthly. Okay? How much will you pay after 20 years? Okay? So once again, guys, the context is you finance a mobile home for $150,000, but because, guys, you finance, the mortgage company is going to charge you interest, right? So you're going to pay more than $150,000 over the course of 20 years. You're going to pay a little bit more because you're going to pay this off with an extra 5% interest that is compounded monthly every month for the next 20 years, okay? So now what we're going to do is, guys, we're going to find out how much will you actually pay in 20 years to pay this actual balance off with interest, okay? So once again, guys, the principal is the initial cost for the home. The home is valued at $150,000. Okay, the interest rate that's going to be added to the debt that you're paying off, guys, is 5%. 5% interest. 5% interest. And you know, guys, we have to change the percent to a decimal. So 5% equals 0.05 as a decimal. Okay? And then it's going to get compounded 12 times because it's compounded monthly. That means it's going to get compounded 12 times within a year span. So the compounded is going to be monthly, which I'm going to put 12x. That means monthly. And actually, I'm going to put that, well, yeah, 12x monthly. I was going to put that black, but it doesn't matter, right? And then the amount of time, guys, that they expect you to pay off this house that you finance is 20 years, okay? So you're on a 20-year mortgage payment plan, right? So we're going to find out, guys, after 20 years, once you pay off this balance, how much did you really pay over the 20-year span? That's what we're going to find out, guys. So now let's go ahead and start, guys. We have A, which is the final amount, equals, we're going to follow the same formula over here, which is P. The principal is $150,000. That is the value of the mobile home that's on the market that you invested in, times parentheses 1 plus, once again, the R represents the interest rate. The interest rate is 5%, which is 0.0, I'm sorry, I made a little mistake, but 0.05 as a decimal. It's 0.05 as a decimal. 0.05 as a decimal. All right, so it's going to be 0.05 over N, which N is how many times it's compounded within a year, which is 12 times, right? Right, parentheses close, times the exponent of N to the T power, N times T power. So N is 12 times T, which is the number of years, which is 20. Okay? So now, guys, we have successfully plugged in this problem, guys. And another thing, guys, that I want to say, guys, that's the benefit of writing everything out is whenever you write everything out, when you do math, right, and you follow along the steps correctly, it's real easy for you to find the small, simple mistakes that you have made. I keep teaching my students that, guys, to write everything out, because when you don't write stuff out and you try to shortcut, then you're going to shortcut yourself from finding out the misconception that you may have, right? So even here, guys, when I made that simple mistake, if I would have never wrote that out, right, I would have not found that little simple mistake that I made while explaining this, and then the answer could essentially been wrong, okay? So that is the benefit, parents that are watching, to make your child or your student to write out everything so everything can be properly seen and everything can go where they need to go. And if there's any mistakes or any misconceptions, you can easily point that out, okay? So I just wanted to explain that. All right, guys. Once again, guys, PEMDAS, order of operations, we always start off with what's inside the parentheses. So we want to simplify what's inside the parentheses first. So I'm going to divide 0.05 divided by 12. That's going to come out as 0.00416. So it's going to come out as 0.00416, right? And then I add this to 1, it's going to be 1.00416, right? We know that, right? And then also, guys, after parentheses, you always want to solve the exponent. Okay, we want to simplify the exponent. All right, so 12 times 20 is 240. Let me check one more time to make sure I'm correct. Yes, it is 240. 12 times 20 is 240. So now, guys, I'm going to plug that in, right, as a simplified version. We're going to rewrite everything, guys, and then we're going to solve. So now, guys, I still have the principal, which is how much the house is worth, $150,000 on the market, times parentheses 1 plus this. So it's going to be 1.00416, right? Parentheses closed to the 240th power. 240th power, all right? And then once again, guys, A is the final amount, guys. So once we plug all of this into the calculator to solve, it will spit out the final amount of what you will pay over time, right? right, over the next 20 years, okay? So let's go ahead and do that, guys. So I have 150,000 times parentheses, I'm gonna put in two parentheses, 1.00416, parentheses close, to the 240th power, and the outside parentheses close, equals, wow, that is a big amount. It equals 406,248. Wow, excuse me. And 20, I'm gonna round it up, 23 cents. So, if you went on the market, guys, and you found a mobile home or a condo or whatever, right, for 150,000 on the market, right, but you financed that at 5%, right? So each month you're gonna have to pay that interest, right, for the next 20 years. In order for you to pay this off, guys, guess how much you're gonna end up paying just to pay this off due to the interest, guys. So I'm glad that I'm teaching compound interest, because I want people and this, grown-ups and students to understand the importance of understanding financing and interest. Because once again, you could be paying on something that only costs this amount, but you about to pay more than twice the amount, right? $406,000 and $406,248.23 is more than twice the amount of 150,000, right? 150,000 times 2 is 300,000, right? So this shows you guys that with interest, you're going to end up paying way more than what you paid for, right? If you're in debt. If it's the other way, where it's an investment, say if you invested 150,000, right? If it's the other way, and you was getting 5% as a return, then this how much money that you will have in your account, right? So when dealing with compound interest, you want to be on the investing side, not the debt side, because regardless, the value is going to grow, whether you're receiving that or whether you're going to have to spend that in order for you to stay within the whatever you're doing, right? So once again, guys, these are great examples, guys, of compound interest within the real world, in the real world context, guys. So thank y'all so much, guys, for tuning in. I really do appreciate everybody that has been supporting my page, guys. Much love to y'all. Until next time.